So putting it all together and seeing it all work out. The last thing we're going to do together is graph and evaluate. This is like a classic 6-point IB level question where it's kind of like considered a quote unquote easier IB question. But this is definitely something that you could be asked to do, where the first thing is to just show that you understand some key values or key things with the graph of a sinusoidal model, and then evaluate the sinusoidal model and understand what it's representing. So we need to graph this guy. We're talking about temperature and time. So we know we're only we know that with time we're only talking about positive. Temperature can technically be negative, but let's think about what we know about the graph right away. We know what the amplitude is. The amplitude is 5, the number in front of the trig function. We know that our period and our amplitude is going to tell us like how up and down we need to go from the principal axis. So we know that vertically, we're only really encompassing a distance of 10 in this graph, right? Because our amplitude will be 5 and 5. So we know that our total distance vertically on the graph that we're going to create is going to be 10. Then our period is going to be 360 divided by b, which is 15. That ends up being 24 if you calculate it, but it's 24. Your principal axis is y equals d, which is 24. So we're starting at 24 as our principal axis, and then we're going to go above by an amplitude of 5, which means we're going to go up to 24 plus 5, 29, or below by 5, so 24 minus 5, 19. So we're going to be between, what did I just say? 29 and 19. So those are the y values that we're going to be between with this wave. Okay, so that helps us to understand how we're building the graph. So we're not talking about negative temperatures at all. And we know that our period, our x value, our time that it's going to take for us, time because our x values are time, the time that it's going to take for us to complete one cycle is going to be 24. And also notice here, it gives us a domain that we need to stay between 0 and 24 with this graph. And so we know our x values are going to be between 0 and 24. So our y-axis can be built on the very far side. And then we know that our y values are going to be between 29 and 19. So we are only talking about positive y values. And then when I strategize, how many am I going to go by? I count how many tick marks I have available to me down here. And I only have 20 available. I need to be able to go all the way to 24, which means I can't go by ones, darn it. So I have to go by twos. But I don't have to label all of them. I can just do that. And I know I'm only going to go to 24. But that's the space I'm encompassing. This is T hours. So now I've labeled my x-axis, which is important, and scaled it appropriately. And then I know that I need to go up to 29 on the y-axis. And it only goes up to 25. I did not do a very good job of picking out a graph paper for you, but I don't have to start at 0. At the x-axis, I do have to start at 0 because I'm going from 0 to 24. But on the y-axis, I only have to start at 19 because I'm going between 19 and 29, so I don't care about 15 or 14 because I'm not plotting any points there. So I'm going to do a little trick here, and I'm going to draw a little hiccup in that x-axis. It looks like a little cardiogram or whatever for like your heart rate, like the beep beep of your heart rate. And all that means mathematically is that you've skipped some numbers. And so you aren't establishing the scale right away, right? Like by establishing this as 10, I've said every 5 marks is 10. Every 5 marks is 10, and that has to stay the same. But if I do a little like heartbeat there, I can start it wherever and then establish the scale. So let's say I wanted to start it at 15 here, but then I wanted to go up by ones. And this little heart rate allows me to do that, to say I've ripped out a part of that axis and then retaped it together starting at 15 because I don't care about anything else below that. And then I can just stop there. I'm going to label this as capital T for degrees Celsius. Temperature on the y-axis, time on the x-axis. I've labeled and scaled my graph. So now I'm ready to start graphing. A few things. You always have your graphing calculator, so you can always just also graph this guy and then take out those key values. These key values that you're going to want are going to be things like maximums and minimums. And I know from creating my window here that I'm going to have an X maximum of like 30-ish because I just created that down there. I know my Y minimum is going to be 0-ish, and then my Y maximum will do 35. And we can see here that we really just skipped a bunch of this Y axis, and we're going to be starting here. But yeah, so now I'm going to go find out what are my maximums and minimums. I'm going to change my window just a little bit. So I can get that maximum over here. There we go. And I do want to know what my y-intercept is. And it's 0.24. Okay, so I grabbed some key things. Maximums, minimums, y-intercept. Those are kind of like the main points that you want to grab. So my y-intercept was 24. My maximum, my first one was 629. So 2, 4, 6, 29. Minimum is 1819. And next maximum is at 30. But remember, I'm only going to 24. So I'll have to stop the graph at that point. But we have a little curve that kind of goes up and down and back up again. And then I'll just go back in and erase where I want it to stop. Oops. Because it's cyclical, there's a few things. This is a middle ground. This is our principal axis, right? So we cross the principal axis at regular intervals. If it takes us 24 to go from 6 to 30, right? Our period is 24. That means that half of the period to go from a maximum to a minimum would take half of that. 24 divided by 2, 12. 6 plus 12 would be 18. And then dividing that by half is 6. I reach from principal axis to maximum in 6. Maximum to principal axis in 6 at 24. So 12, 24 would be another point. Principal axis to minimum in another 6. 12 plus 6 is 18. 18 plus 6 is 24. I reach the principal axis again at 24. So I've completed one whole cycle within that. Okay, now I've graphed it. It then said to evaluate. We want to find the temperature inside Jod's caravan at 2 p.m. That is 2 hours after noon. Remember that T is time after noon. So I say, okay, that means T equals 2. Go ahead and find T of 2 for me. It ends up being exactly 26.5. because sine of 30 is one of those like special right angles. And so sine of 30 is a half. So it ends up being one of the very few sine values that we get that ends up being an exact number as opposed to an irrational number. Okay, t equals 9. Go ahead and find that for me. That ends up being about, to 3 sig figs, 27.5 degrees Celsius. Just by plugging in 9 for t, so 9 times 15, and go for it. We then need to find the minimum temperature, which when we graphed our graph, we already grabbed it, right? Our minimum temperature is here. It's at 18, 19. So we knew that our minimum temperature, which is your y value, right, is 19 degrees. And then it says the time at which it occurs. Well, that's t equals 18, which is 18 hours after noon. So that's 12 hours would be midnight, and then another 6, right? 18 is 12 plus 6. So it's nice to kind of break things up into chunks of 12 until you get close enough. So noon plus 12 would be midnight, and then midnight plus your last 6 would be 6 a.m. is when your minimum occurred. Okay, that's it for our first lesson, and I will see you in class.